We're going to be looking at specific trigonometric substitutions that can help us integrate, and we'll need to pay attention to forms. So first, if your integrand, the thing you're integrating, contains something of the form a squared, square root of a squared minus u squared, where a is some number and u is an unknown, then you'd like to substitute u equals a times the sine of theta. Right, we're going to change our expressions to have them in terms of theta. And notice then that du will be a times the cosine of theta. If our integrand contains the form the square root of a squared plus u squared, then we'd like to let u equal a times the tangent of theta, and this would mean that du equals would be a times the secant squared of theta. Finally, if our integrand contains something of the form u squared minus a squared, then we'd like u to equal a times the secant of theta, and this would mean that du equals a secant theta tangent theta. So just be aware of these as helpful substitutions. As an example, let's consider the problem. We'd like to integrate x squared over the square root of 9 minus x squared dx. Now, as it stands, this can be difficult in terms of x, but we notice that our denominator has something of the form a minus u squared, which means that we are going to set x equal to 3 times the sine of theta. And this also means that dx equals 3 cosine theta d theta. Now, what does this type of substitution do for us? Well, this changes our integral a bit. Since x equals 3 sine theta, then x squared becomes 9 sine squared of theta over, this will be the square root of 9 minus 9 sine squared theta times 3 cosine theta d theta. So we've basically converted our integral to go from being in terms of x to being in terms of theta. Simplifying, I need to notice that 9 minus 9 sine squared theta in the denominator, I can factor the 9 out, which leaves me with the square root of 9, which is 3. And I'll be left with 1, the square root of 1 minus sine squared of theta. And I have to recognize that 1 minus sine squared theta is the same thing as cosine squared of theta. And its square root would be cosine theta. So if I can recognize all of these things, that my denominator becomes this, which means it will completely cancel out. And so my integral reduces down to 9 times the integral of sine squared of theta d theta. In order to go anywhere from here, I have to know my half-angle identities. And either I know my trig identities to help me, or I don't. And if I don't know them, I'm just kind of stuck. There won't be a problem this extensive on, say, like an AP exam. It's too dependent on knowing a lot of different trig identities. But this is the kind of problem you should be aware of some trig substitutions, even if you have to look them up. Sine squared of theta is equal to 1/2 times 1 minus cosine 2 theta. So my integral becomes nine times the integral of 1/2 times 1 minus the cosine of 2 theta d theta. This half-angle identity you may or may not have memorized. And again, this wouldn't be something that would be on an AP exam. It's something that you just have to be aware exists so you could look it up if necessary. And this becomes 9/2 times 1 minus cosine of 2 theta d theta. This we can integrate, right? The integral of 1 would just be theta, so we've got 9/2 theta. The integral of cosine 2 theta, well, that must have come from sine 2 theta, and I would have, when I took the derivative, multiplied by 2, and so for it to not be there means it got divided out, which is why the 9/4 would be there, plus c My answer is in terms of theta, which is okay, but unfortunately it was originally given to us in terms of x, so we need to go back to put things in terms of x. Notice that we said that x equals 3 sine theta, which means that sine theta equals x over 3. The sine of theta must be x over 3, based on what we set x equal to be. This means that theta must equal the arcsine of x over 3. And, using a triangle, if the sine of theta is the opposite over the hypotenuse, then by the Pythagorean theorem, the adjacent should be 9 minus x squared, and the adjacent over 3 would be the cosine of our angle. Right. With all of these substitutions in mind, then, we're left to go back in terms of x. This will become 9/2 times the arc sine of x over 3 minus half of x. Why is that? Well, because sine of theta equals x over 3. Cosine of theta is something divided by 3, and so when we simplify it down, we're left with this. These would be potentially the kinds of problems that a university course would expect you to be familiar with, right? To know these kinds of processes. But again, there's way too much involved for this to be a typical AP exam problem.